Did I get that right? Yes. Good. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Although we sometimes do not code a complete game live on stream, and as those of you who were with me yesterday know, regrettably, we may have gotten a little carried away with doing our lighting. When I initially started the series, I was just going to do basic 2D rendering, but in that way that it just ends up, sometimes when you're programming, you end up going too far on things. We ended up doing 3D rendering because why not? And we ended up deciding to do lighting as well, which of course is very complicated and intricate. So as a result, you end up using a lot of GPU stuff. Now, yesterday was the first time we hit this point, but we actually are able to get into a place now where our shaders can crash the graphics driver, which is not a bad thing necessarily, because during development it's not uncommon to crash a graphics driver. That's just something that can happen, so no real big deal there. But what that basically means is if we want to continue doing lighting work and debugging, we are probably going to have to finally bite the bullet and upgrade the Handmade Hero streaming setup to have a new machine and to stream from a secondary machine, so that when we crash, it's no big deal. We just reboot or recover from the crash, either or, and the stream can stay live and you can still see what I'm doing and hear me. So I'm going to go ahead and do that. The problem with that is it's going to take a little while. It's going to take at least a week or two to order some new parts and put together something that's going to be able to do that for us. So I won't be able to stream again until like 2 weekends from now, let's say. Now, this is actually pretty handy because I am going on a brief vacation. I'm going actually to visit Jeff coming up here. And so I wasn't going to be able to stream this weekend anyway. So given that that's the fact, now is probably a good time to do this anyway, since we won't actually miss a stream weekend that we wouldn't have missed anyway. So if I do that now, we can get a new streaming setup set up by the time I would have been back to stream 2 weekends from now. And so that's probably the right call. So I'll just go ahead and get that. I can get it all ordered. And then when I get back from visiting Jeff this weekend, I can put things together and hopefully get it working by the time we need it to work on stream. So I'm going to go ahead and get that process started. It'll just take a little bit of research for me to figure out exactly what the best way is to set up an external streaming machine. But given the fact that so many people stream nowadays, I can't imagine that there isn't some pretty well documented stuff out there about what kinds of setups are the best to use for something like this. Okay. So that's really it. What I don't want to do any development today because I don't want to risk another crash that'll take the stream down, and we almost certainly will hit one as we try to debug this. Also, since we're doing some fairly heavy graphics debugging stuff anyway, having a new machine that we could run a graphics debugger on, which is one thing I will make sure that I get, is some kind of machine that can run, like Nsight or RenderDoc. That'll also help us debug the lighting, and I can show people how that normally works if they've never seen it before. It's not very complicated, so I'm not sure that's that valuable, but at least we won't have to debug blind like we have been doing. So that's what we will do. In the meantime today, since I already said there was going to be a stream, I figured I might as well show up and do some streaming. If anyone wants to, we can do something else, something that does not require working on the game right now, in the state where it is, where it's likely to potentially crash the stream out until we debug all of our lighting code. For all we know, we don't even have a bug in the lighting code that's causing a crash. It could just be that what we wrote happens to crash the AMD driver. Like, I have no idea, because we haven't looked at it since it crashed, right? We just left it where it was, so we haven't even looked at what the cause of the crash was yet. Yeah, it's really entirely up to you folks, and we can just take questions for a little while, and just do a chat if folks want to stick around for that. Or we can just end the stream. We can do whatever. But like I said, I don't want to run the game anymore because I really don't want to. I really don't want to have to try to prevent a crash of the graphics driver. If I knew that graphics drivers never crashed when you gave them correct code, I wouldn't worry about it. I'd say let's just be really meticulous, but what I actually know from my real experience in the real world is that it's just not the case that you can analyze code to know if it's going to crash a graphics driver. Graphics drivers can be crashed with perfectly correct stuff, so you really have no idea when you run something whether it's in crash zone or not. Let's see. Valbus says, how do you write a program that is graphics driver crash aware? Well, it really depends on what kinds of graphics driver crashes you're trying to prevent. So there's two kinds of graphics driver crashes that you might be trying to prevent. Or I shouldn't say prevent, because you're not preventing it. What I mean to say is two ways in which the graphics driver could crash your program, and you want to prevent it crashing your program, right? So one way the graphics driver can crash and cause your program is the more difficult one. That's if the graphics driver is just crashing asynchronously of your program in a thread that it spawned for your program, right? So let's say that you write a program that, creates a, OpenGL surface or whatever and starts rendering to the surface. And, as a result, when you run the program, you can see that there are lots of graphics driver threads that are getting started potentially that you didn't ask to have started, but that did start. Do we have Process Explorer on here? Let me just grab that. I'm gonna grab this. This is one of those Mark Rusinovich utilities that are pretty handy to have around. So here we go. So, if I'm, in this case, it was OBS that got taken down because that's what, takes down the stream. So what I'm wondering is, hey, what does OBS look like in terms of threads that are run? So here's the, yeah, that's okay. So here's the thread list. Right? And for those of you that are unfamiliar with Process Explorer, again, it's just a really handy application that uses internal Windows systems API. Well, internal is the wrong word. It uses kernel APIs, basically, to iterate over the information about running processes at any given time so that you can get insight into how they're running. Now, if you take a look at how many threads are launched right now on behalf of OBS, what I hope you can see here is that the start address for these threads, meaning where their entry point was, is largely not entirely inside OBS. A lot of it's in the Microsoft Visual Studio CRT, right? I mean, look at how many DLL entry points have been called here. Each one of these is a separate thread that the CRT started. I assume this is because they're using the MSV CRT, and every time they create a thread, right, you're going to get this. I don't use the Microsoft Visual Studio Visual C CRT at work myself, so I don't really pay much attention to these sorts of things. But you can see what happens when you do, and when it's a DLL. However, the more important part sorry to go down that route, I don't know why I mentioned that, just kind of interesting to see how many of them popped up. The part that we actually care about is down here, right? So you can see that ATI has created a large number of threads. This is, all of these threads, for example, at a minimum were created as part of the ATI driver and are in the ATI driver sitting around, right? Those threads could crash, and they don't need any help from you to do it, right? So the first way that the ATI driver could take down your process is you may not even be calling the ATI driver at all. It may not even be doing work on your behalf. And if somehow the bugginess in the other, like when the other app, in this case like Handmade Hero, runs a shader that causes the graphics card to crash, if that cascading crash causes threads in your other app that you're trying to make safe, if they crash, then you will literally get whatever the kind of crash it is, like an out-of-bounds memory access or who knows what. That fault will happen completely unprovoked by you. So that's the hardest kind of crash to recover from on behalf of the graphics driver. That's thing one. Thing two is the much easier kind of crash from the graphics driver to prevent. And that kind of crash is just things that will happen on the graphics driver that you don't expect to happen, but that do happen when the graphics card gets reset. So that stuff, like let's say that you're going to do something where the graphics card gives you back a pointer, right? So let's say you go and you're in DirectX or something like this, and you lock a texture surface, or you're in OpenGL and you lock a buffer. You say, give me a pointer, I'm going to write to the memory of this buffer. And you write to the memory of the buffer, and then you unlock it. Now, 99.999999, as I said before, % of the time, that's just going to succeed. You're always going to get the buffer lock, you're going to write to it, you're going to unlock. So if you don't think about it particularly hard and you just leave that code in there, you're never really going to crash. You can ship that and it'll probably work most of the time. However, if the graphics driver gets stalled or gets hung or gets reset, as in the case like it did on yesterday's stream, all of a sudden, a bunch of calls to the graphics driver will start to fail. They'll fail specifically because the surface, all of the stuff that you previously allocated, like your context, OpenGL context, your textures, all that stuff, are gone now, right? They just got nuked. And so all of the calls that you're going to make will fail. All of them. The graphics driver will no longer be able to respond to them. And so even if the graphics driver itself hasn't really had any problems and isn't crashing, it may cascade into a failure of your app where your app crashes because it's seeing behavior it almost never sees. So if you want to make an app graphics card crash proof, those are the two things you need to guard against. So one of them is fairly straightforward, although somewhat time consuming. That is making sure that nowhere in your app do you request something from the graphics driver and assume that you will get it back. You always have to check and see whether or not the graphics card has gone down. So are you starting to get failures? And if you are starting to get failures, make sure you check to see if your context is still valid. And if it's not, shut everything down and restart, right? This is the kind of engineering most apps just don't do. It's the kind of engineering that unfortunately, like basically all libraries don't do. So, as far as I know, like SDL, those sort of things don't do this kind of engineering. So there's really no likelihood that an app has any of that in it. That is not a hard problem to solve, but it is a time-consuming problem to solve and does cost engineering resources. So most people don't do it. The first one, which is the faulting inside the graphics driver itself, that is much harder. In order to catch that, you have to install a fault handler. So you're going to have to put in like a Windows vectored exception handler, for example. Something that will catch faults in the application and then respond to those faults in some way. So for example, if you catch a fault in the graphics driver, you're going to want to do stuff like shut down everything and try to force close it, try to force unload the graphics driver, who knows, and then try to reload it, right? Now, the good news is for something like OBS that's just supposed to be recording, in that particular case, you have a couple easy outs. When that fault handler hits, all you really have to do when the fault handler hits is just make sure you flush the stream properly. That's the real shame about OBS, is that they put in no protection for flushing the stream, because that's really all they would need to do, right? All they would need to do is protect and stream flush on crash, and most of these would be fixed. Now, I would argue they should just flush the stream periodically anyway. I don't really know why they don't. It doesn't make a lot of sense to me, but they don't. Either or, assuming you want to be graphics proof, ignoring OBS, if you can just shut down gracefully, that's really all you need to do, because you can shut down gracefully and then relaunch your own application, right? So for example, you can write a launcher executable that just loads another executable, let's say, or creates a process and launches that executable. When that executable goes down, it just restarts that executable, right? So then all you have to do is the executable that's the real executable, the one that gets started by sort of the launcher, that secondary executable, all it has to do is trap the fault, make sure that it hasn't corrupted any files, right? So if there's something that needed to be flushed, flush it. A save game file, the movie stream. Then go ahead and shut down, like just exit process, and let your launcher restart you, right? So that's one way you can also make it so that, forget it, like assume the graphics driver is never coming back again and that you won't be able to reload it from that executable anyway. Just double insulate yourself, right? So that's another way that you can do that. How many episodes are remaining? Estimate. I don't really have an estimate for how many episodes are remaining, because we tend to decide to do things fairly randomly. Like if, I think it might be interesting to do some lighting, we do the lighting, but that's like not something that was ever like on a schedule. So I don't really know how many episodes there are. It's just until we feel like we're roughly done. I've said probably 600 as a minimum. I just thought that sounded like a fairly reasonable amount of time. But I don't know. Sergeant Rumby says, do you use C++ features like templates? Do you use polymorphism in your own projects? So I don't use templates in in my own projects, no. The reason that I don't use templates is because in my experience, they have a lot of negative aspects to them, and they're not very good at metaprogramming. So I tend to try and just write code that generates code rather than using C++'s templates. I find that keeps compile time down, it keeps readability up, and it gives you much more power than a template does, because templates are very, very weak. They're extremely weak in terms of being able to actually do metaprogramming. Do I use polymorphism? Yes, all the time. But we use polymorphism on Handmade Hero as well, right? I just tend to code it myself. I don't use classes and virtual function tables for that. I tend to just use type fields. So you can pass around something called a node to a bunch of functions, and the nodes have left and right pointers or something because it's a tree or like an abstract syntax tree. But then there's also like a union inside it that has a bunch of different states of things and a type field that tells you which one it is. That's polymorphism, right? Polymorphism is just a general term for saying that you can take an object of one type and pass it off as an object of another type, right? Well, if you have a struct, and that struct can be used by multiple routines, regardless of which type of thing it actually is, and there's different data layouts depending on which one it is, that's, polymorphism. And same with switch statements, right? Switch statements that look at something and do a different thing based on it. That's just another way of implementing a virtual function, right? And so I don't tend to use C++'s features for either metaprogramming or polymorphism because I just don't think they were very well designed. But I don't mind those concepts. I think the concepts are just fine. C++ just didn't do a very good job making them, making utilities for you to use to do them, right? BPAF asked, what do you think about the CRTP to do polymorphism? And he linked to curiously recurring template pattern. So I've never heard that term before, but maybe I will recognize the actual the actual thing. It's interesting that I haven't heard of it. Maybe I have heard of it and I forgot, because it says here that the name CRTP was independently coined by Jim Coplin in 1995, who had observed it in some of the earliest C++ template code, as well as in code examples that Timothy Budd created. The interesting I say it's interesting is because, I remember reading Jim Coplin's book. I think it's called the LSD book, by Scott Myers, I want to say. I think. And I used to read the C++ report, and Jim, if I'm thinking of the right guy, Jim Coplin used to write in that as well. Anyway, let's take a look at what this says here. The curiously recurring template pattern. It's got a template, class T, methods within base can be used, template text measure derived. Wait, what? Oh, I see. Yeah. All right, I see what we're talking about here. I should probably put this up on the screen so that folks can can see what we're talking about here. Let me open, I guess, like a dummy. Let me just open like a dummy file. Do we have a temp directory? Yeah. All right. So here, I'm just going to type in the example from the Wikipedia page so you can see what I'm talking about. Or rather, I should say what I'm discussing, because this is basically what the questioner was asking about. So we don't use this syntax very much on Handmade Hero, or at all, I guess, because we don't use templates on Handmade Hero. So let me briefly just explain how these work for anyone who isn't already familiar with them. So for whatever reason, and I do not pretend to know the reason, it's probably in the D&E. I don't really know. The D&E is a book, The Design and Evolution of C++, which is like a history document that explains like the reasoning behind some of the choices in C++. Which it's fascinating to think that there were reasons behind the design of C++, but apparently there were. So if you put aside the why and just deal with what actually happened, what goes on here is that there's a template syntax you can use in C++ that allows you to specify inside these greater than or less than symbols, right? Inside here, you can specify some things that you do not yet know about the code that someone can then later specify. So for example, this class doesn't need to be here, so we can ignore that. Class instructor is synonymous. The only difference is whether things default to private or public, so you can ignore that part of it, especially for this discussion. We don't care at all, so just pretend these are structs instead. There's no difference for the purposes of the example that we're going to be talking about. So you've seen the struct part before. So here we say struct base. We're defining something called base. If it was formatted like mine, it would probably look like this, because I use lowercase for types, but again, it doesn't really matter. It's just, that's just convention. So in the example, they've got a thing here where they're declaring a structure called base, and they're using this syntax, this template syntax. The template syntax basically says, there's something I don't know. It's going to be, let's say, a struct t, right? That means t is the name of some type that is not yet known. So inside the struct, let's say I wanted to have a member, right? Like I just wanted something in the struct that was of that type, right? So here we have a template. We're going to say base, and we're going to say that we've got this type we don't know. Ignoring this part for right now, let's now say that we wanted to actually use this. So we've got some function in our program that looks like this, and inside here we want to use one of these things, and we want the thing to be an integer, right? Well, then what we can say is base integer, right? My base. Now I can do my base dot the thing equals 5. My base dot the thing, or int q is my base dot the thing, right? And my base dot the thing is an integer everywhere because that's what we asked for, right? Now this doesn't give you the ability to actually do anything useful with this, unfortunately, in terms of type movement. The reason being that these base classes are all distinct, right? So this struct base int, if I declare a struct float, and I've got two of these are not the same type. They're completely different types. They're exactly analogous as if you had done this. And when I say exactly analogous, I mean literally there is no difference between having done these two things. Okay? So you get no bonus polymorphism out of this. You get no extra utility out of this. It doesn't really help you much other than to save the typing of typing this twice, right? So really all that part of it is really doing, and you can do, there's more to templates than just this, so I'm not trying to suggest that's the only thing you could do with them. But that part of it, the just specifying a type there, is really just designed to do the most basic kind of generic programming, where it, like for example on Handmade Hero, you've seen me, and I've mentioned templates when I do this, you've seen me do something like this, and then something like this. Right? Well, if equivalently you wanted to write those together, you could do something like this. And now you've got a v2 that can just be specified with whatever you want. So when you're going to go and use it, you know, you can do something like this. Right? And furthermore, you can just sit around generating types all day. Right? And so you can see why this has at least some utility there, because if you don't want to have to cut and paste the code, you can, you know, just use this to instantiate it. The problem with templates, as with everything else in C++, is the instant you want to do anything more complicated with the thing that you just made, it entirely falls apart. So, you know, if you want to start doing things like saying, well, okay, you know, I wanted to make it so that I've got something that does, you know, a combination of this type of template version and this type of template version inside this routine when I want to, you know, do some kind of processing on them and I need to detect which one's which. It's like all of a sudden all of my stuff has to start being templatized on like 50 different things and getting specialized and all this sort of stuff, and it just creates this incredible rat's nest of code that gets generated at compile time that leads to super long compile times and just really bad kind of readability, because you can never, it'll never show you the code it actually generated. It's just bad news. It's better now than it was. I have a stronger aversion to templates than somebody who started with them today with my same brain would. The reason for that is, at least nowadays, at least say Clang, I assume Visual Studio as well, but at least Clang, compile them properly. One of the interesting things about templates when I learned to program templates back in the early days was that the compilers did not compile them properly. Not only that, but the error messages that they gave literally would stop working, meaning when it tried to print out an error, it would often reach the limit of the size of an error it could print and just truncate the error message, so you couldn't actually see the error message. I'm not making this up. Debuggers often couldn't inspect them, so you'd end up with templates that were like uninspectable. You just couldn't see what was inside them in the debugger. Just a lot of really bad stuff. And so nowadays, I still don't think templates are good. They don't lead to cleanly written code for doing the kinds of things that you want to do with them. But they're a lot better than they were, which is why I say that if somebody wants to do something like this, I'm not going to get too angry about it, because it's relatively straightforward. It does work. You can inspect it in the debugger now. Back in 1996 or so, when I would have been first using templates, 95, 96, I would, at this point, say, you know, if I went back to that day, I'd be like, do not touch templates for a decade. Like, until 2005, don't even think about using these. And then maybe sometime around there, you could start to think about using them, right? But they were just awful at that time. Not that people didn't still use them, but it was a very bad idea. All right, so anyway, that's what templates are, enough to understand this example. So what the person wrote in to ask about was that if I declare a template like so, what do you think about the pattern of having a derived class that inherits from a base class that is templatized on the derived class itself, right? Now, you may be asking, and rightfully so, what is this public base derived thing here? Because again, for those of you who aren't C++ people, you may not really know because we don't do that on, we don't really ever use that on on Handmade Hero. Well, if you have a struct or a class and you want to essentially extend that class, and that struct. Classes or structs are interchangeable, so I just use the two terms interchangeably, so I apologize for that. So if you have a struct like, say, this base here, and I could make it a little simpler by taking the template out of it. Let's say I just have a class A, and it has an int in it, and then I have a class B, and it has a y in it, like so. Right. So normally, let's say that I wanted to extend this class and I wanted to put some extra information in it. Now, you know what? This is a bad example. Let me do something you can actually relate to so it's a little clearer. Let's say I've got entity, because that's a more common thing that people might use for subclassing, right? And inside the entity, I have got some, generic information, like I've got like the position of the entity, and maybe I have something like its radius or whatever. But then depending on what type of entity I have, I want additional information about that entity. Now, we've seen different ways of doing this, like on Handmade Hero, we'll often do something like we'll make a union, and then we'll do something like saying entity ghost, and the ghost has, a spookiness value. And then what we'll do on Handmade Heroes, we'll say, all right, here's entity ghost, here's enum entity type, and we'll have like entity ghost. Right, that's the standard way we might write something like that on Handmade Hero. The way a object-oriented programmer writes this most of the time, who likes inheritance, is they use this syntax, which is the syntax for inheritance in C++. What it is it's a colon after the type name that says, anything that I list after that colon is going to be something that I include at the top of myself, basically. So if I say, oops. Okay. So if I say this, then what this public entity part here means is just that I've got this struct stuck on top of me. So this basically becomes this. Right? It graphs whatever you put here onto the top. And that's all it does. Right? It doesn't really do anything else at this point. So, why do you want this? Well, as you can see, this is sort of a way of doing the same sort of thing we were doing here, building composite types that have all the information in them. And furthermore, C++, once you've specified this, will do you a nice favor, which is it will make it so that you don't have to cast if you want to go from one of the more specialized classes to one of the less specialized classes, or in our case, structs, right? So for example, if I'm sitting around and I have an entity ghost, like so, right? And I have something that expects an entity. So let's say I have a function and in here we're going to do something to that entity. Then when I am going to be somewhere else with one of these entity ghosts, like so, normally if this were just without this syntax, the public entity part, normally I wouldn't be able to do this, right? Because this is an entity ghost, and this function requires an entity. So when I call foo, I'm going to be calling ghost here. I'm going to be passing an empty ghost pointer. It shouldn't work. It should give me an error. But because I said that this entity ghost always includes entity at the top of it, it's essentially as if I had one of these at the top, and whenever you want to call something that would have used it, it just casts it for you implicitly. Because remember, any pointer to an entity ghost is basically a pointer to an entity as well, because the members at the top are the same. So anything that would have been code that would have been generated in here to work with P and radius, whether I'm pointing to an entity or an entity ghost wouldn't matter because they're in the exact same places, right? Okay. So that's how inheritance works, right? So now let's get back to the actual question at hand, now that we've explained the things in here that we don't normally see on Handmade Hero. So in here where we have struct entity, we've got the P and the radius, the entity type, the ghost, whatever, that sort of stuff, right? This is the Handmade Hero way of doing something. We're going to say, let's pretend we're not going to do it that way. Instead, we want to do it, some other way, like this inheritance way. Well, once we start doing things in the inheritance way, what you can see happening is that all the stuff we take for granted on Handmade Hero suddenly starts to go away a little bit, right? Because the base class that you're inheriting from doesn't know and can't know what the derived class actually was. So for example, inside, when we're dealing with something of this base class here, let's say we have a struct derived, base derived here, this fellow, right? Let's say in here we have an int x, right? And if inside the base class there's a function that wanted to be able to know whether it was actually one of these or not, right? Because remember, I should probably leave this in here because I'm going to probably refer to it, right? Let me leave this because I can show you more clearly in here. Let's say that we actually built this out a little bit more, and what we wanted to do was, like, inside foo, we had a bunch of stuff we wanted to do here. That was like, oh yeah, the entity P is going to be offset by something, and then the entity radius is going to be, offset by 1.0, I don't know, right? Something like this. That all works just fine in C++, right, with this inheritance model. The problem now comes if I wanted to do something like, you know what? I really wanted, if it did have a spookiness to it, right? If it was a ghost, then I want to do something differently. So, I really wanted to do something like, if I am a ghost, right? Then, then get, shrink me to 0 or something. I don't know, right? Like, imagine you just have something special you want to do in that case. So C++ doesn't really handle these sorts of things with any kind of grace. It's one of the really big problems with their inheritance model. RTTI isn't something you can actually persist across builds of your program, so you can't really use what's called runtime type information, which is a way of figuring out an identifier based on a type. It doesn't really work, so it's pretty much out of the question, so you can't use that to ask whether you're a ghost. There is no way to generate an enum. If C++ was sane, there'd be a way to just generate an enum in a predictable fashion that was stable across runs that you could use and just have that be a type field that you could access in size entity if you wanted it. Of course, you can't get that, so that's out of the question. That's, of course, why I always write it this way, is because this basically handles all cases. You can't do that in C++. So you start to have to use these other, like, really roundabout ways, like saying, well, okay, even though all I wanted to do was check if I'm a ghost here, which should have been a relatively simple thing to do, I'm going to have to start introducing something to help me here. One thing they could do is virtual function calls, which are basically based off of whatever the derived type was. I can have a virtual function call which says, like, am I a ghost? Right, which I could call, and it could return a Boolean that tells you whether I'm a ghost. I could inflate the base class to actually have an am I a ghost, but that's basically like adding an enum. So at that point, you've lost the benefit of the inheritance. So the virtual functions are really the only way to do it. I won't go into detail quite about how virtual functions, because they don't matter for this example, but that's one way you could do them. The object-oriented programmer's sort of fallacious reasoning usually leads them to do something like, well, you should break this down into a virtual part that will be different for the ghost. So maybe it should be something like, you know, get foo radius that you call on the entity that allows it to do this or whatever. Also, this would probably be a member function in an object-oriented programmer's world, but that's beside the point. But you just get into this really nasty world of nastiness, right? So another weird way you can accomplish the same thing, though, is by looking at this pattern that that the original questioner asked about. One thing you could do is say, when I derive from a type, instead of using it as a polymorphism, as something for polymorphism in the top-down way, right? In the way where I'm like inheriting from an entity base class that has the basic things in it, and instead I'm, you know, going to and I'm stacking that on like at the front of my struct so that I could interchangeably use myself as what type I actually am and that type. You could instead effectively flip things around, right? You could say, well, all right, this type is actually the type that's going to be more primal. And instead what I'm going to do is I'm just going to make whatever this utility class here is that I've written, I'm going to make that templatized on me. So it can do stuff based on what I want it to do, right? Now, you can do a lot of different stuff with that, right? Like you can imagine that this base class now can have stuff that operates on things of this derived type. So for example, if this thing does have an int x int y in it, and now we have a thing that's like inside this base class, well, first of all, yeah, again, member functions are something we haven't really talked about either. Member functions are things that are part of a class that operate on the things in the class. But yeah, so I'm trying to think of like what the cleanest way to show something like this is. It's been so long since I programmed with any things like this that I'm sure I can think of a reasonably interesting use case for this. It's just that my brain has long since passed by these sorts of things, so it's a little bit hard for me to immediately think of something that's going to resonate and be like, oh yeah, that makes sense. So let's say that we have what's going to be good? I don't suppose the Wikipedia article has an actual good example of something that I would want to do, does it? Typically, the base class template will take advantage of the fact that member function bodies are not instantiated until long after declarations, and will use members of the derived class within its own member functions, which is what I just said, via the use of the cast. But they don't really, they don't really do anything particularly interesting here. Here we go. Object counter. So maybe this is useful. Let's see. The main purpose of an object counter is retrieving statistics of object creation instruction for a given class. This can be easily solved using CRTP. They basically go on to to basically just use this as a way of doing injection. Let me skip that because since polymorphic chaining is given as an example here, maybe we can just skip directly to that, which I think is what the original question was about. And we'll see if we can reasonably get this. Maybe I should bring this up on the screen and I can just walk through the example. CRTP. Here you go. So I think this, and perhaps its related one, polymorphic copy construction, is mostly what the original questioner was asking about. But I don't really know, obviously, because they just said polymorphism in general. So maybe they didn't have either of these two uses in mind. I'm not sure. This is the more concise one, so we could look at this one first. But basically what they say here, right, when using polymorphism, one sometimes needs to create copies of objects by the base class pointer. Commonly used idiom for this is adding a virtual clone function. Defined in every class, the CRTP can be used to avoid having to duplicate that function or other similar functions in every derived class, right? So you can see they've set up exactly the same thing as we were talking about. Here is the base class. I'm sorry, here is the generic class. This is actually not the specific one. It's just sort of a thing that creates the virtual functions, which again I guess we'll have to talk about. Basically what a virtual function is it's a function that is dispatched automatically based on which actual type of object you have. So for example, in Handmade Hero, we typically implement this behavior with a switch statement. We will have an enum stored in the structure that says, I'm this particular type. And so when someone wants to do something specific based on that type, there's a switch with the type, and then you do a different case per object type, like whatever the thing is. In C++, the method they built in for that was virtual functions. What they do is they add a hidden pointer. You can't see it. It's not ever shown, but it's there. So it adds a hidden pointer to the top of each struct. And, well, it doesn't have to be in the top of the struct. It just has to be in a predictable location, but point being probably at the top. So there's a hidden pointer which points to a table of function pointers that can be used to call the different functions depending on the type, and it will just dispatch through them. So for example, when you see here, we've got a template type name derived, class shape, CRTP, public shape, right? It creates a virtual function here that overrides, that's the term that's normally used for creating one of these, the one that's in this base class. So when someone has a shape, they don't necessarily know which kind it is, so they don't know it's a shape CRTP template or any of the other things. What they will basically do is when you hit this clone, you try to call clone, it will look up into the pointer table. Because it's actually one of these, that pointer will be pointing to the pointer table for this particular type, which will have a pointer to this function, and it will call this function if you had a shape CRTP as the type you were working with, right? Now there's going to be a different one of those function tables for every one of these different parameterized types, but we'll get to that in a second. Okay, so all this base class does is set up the fact that there is going to be a clone. After that, we then have this template type. The template type takes whatever the most derived class is going to be. So for example, a square or a circle, they're defining these other types in the future, right? I don't know why they thought they should introduce a macro here, because since this isn't about macros, it would have been probably much clearer to not do that, but what can you do? So anyway, this CRTP class implements clone for derived, as they say. You can see how it's doing this clone, right? It's saying, oh, okay, when I want to clone something, what I want you to do is create a new derived class and pass to it whatever the, I want you to use its effectively copy constructor. I want you to basically take, there's so many things in here that we don't cover in Handmade. It's really hard for me to do explanations because every time I want to refer to something, I'd have to explain it. Every time you call this clone function, you're basically just going to call the copy constructor of whatever the derived class was. So it's basically just a way of saying, oh, okay, since I don't want to have to type this every time in every derived class from shape, I'm going to make this ridiculous template that will then inject that function using the actual derived class itself into every of my derived classes so that they all can do this, right? Now, the hilarious thing about this, I mean, you know, you can probably predict what I'm going to say. Just look at this, right? It's so convoluted. Like, what you wanted to do is nothing like what this looks like. All you wanted to do was write a function that said, hey, I'm going to write a function called clone. Whenever you derive a class from shape, I would like you to call the copy constructor on that derived class inside clone, right? And I'll just try to hammer this point home because this is an extremely simple example, and yet it's still so laughable about how bad C++ is at doing this, right? So here's what I wanted to have happen, right? Here's what I wanted to have happen. In fact, maybe this is what we'll talk about today because it's worth noting, it's worth examining specifics about why I rag on C++ so often. And literally any example of how to do something in C++ using templates, classes, whatever, literally any example shows you why it is such a poor language. You can literally take any example that someone gives, and it usually takes only a few seconds to see how bad they did at creating the thing that you would have wanted in that scenario, right? So here we go. Let's think about what's actually happening in the code right now. All right, what we actually wanted to have happen. Let's write that first. So here's what I've got. And I'm going to call it a struct because, again, I'll try to keep it as friendly to people who are used to the series as possible, right? So here's what it would look like in Casey land, right? It would just look like struct shape, like so. And all we wanted to do in our program is we wanted to have something that would do that, whatever that clone function is, right? So all we wanted to do was say, all right, we need a function called clone. It's supposed to take a shape. It's supposed to clone that shape, right? So this is the function that we wanted to write. Now, if there weren't any pointers in here, in particular, right, then the amusing part about this is that actually it would be incredibly easy the way we do it on Handmade Hero, even if it's a derived class, right? So on Handmade Hero, again, the way that we do this is we would say shape square, shape circle, I don't know, seem fair? We have a shape, it's got a position, we've got a radius in the circle one, we've got a dimension x and y. Oh, well, it's a square, actually. So let's call it a rectangle. Because otherwise you'd just probably still call it a radius. So at least the data members will all be different, right? So anyway, we've got a shape rectangle, a shape circle. In the Handmade Hero way, we would do something like shape type type, right? And then we'd have a union that would be like shape rectangle, shape circle. Okay? So in the Handmade Hero way, if you wanted to write a clone function, well, all you would do is, however you would do the alloc, you know, you'd do a push struct or something like this of shape. And then you would just do result equals shape. Right? That's it. Okay? So the implementation in Handmade Hero style code is 3 lines long. Pretty straightforward, right? Now let's suppose there was something in here that was a little more complicated. For whatever reason, our circles have a data block. The data block pointer is going to have to get duplicated in some way, whatever. So then what we have is this. right? So inside here, we've got whatever needs to happen to data block in order to clone it, because it has some kind of special operation, all right? Again, extremely straightforward. Look at that code for a second and just consider how easy it was to write this code. Also consider how easy it is to read, right? Now let's try to start writing this in C++ instead. All right, so first attempt at C++ to write this. We're not going to use this pattern yet, right? We're going to save this pattern for a minute and get to that in a second. Okay, so first attempt to do this in C++ is just do it the straightforward way, okay? So first of all, we have to change the order of these two things. And then what we have to do is go, okay, we got to bring in the shape here. Right? So now we at least have these types. But now we want to write a clone function. So we want something that does this. Right? How do we do it? Right? What are we going to do? So, a couple options we have. First option is we can try to write it effectively this way, but just much more laboriously. Right? Because we have no idea what the maximum size of one of these is, right? So for example, one thing that you would have done in C++ if you wanted to make things simpler for the programmer is you would have had a trivial way of saying all derived classes have to be the same size, right? That's the way this works. So if you wanted to make things easy for the programmer so that they could still write this code that I wrote before, right? Because, and again, let me just hammer this point home. It's crucial to understand that if your language features meant to empower the programmer to do something new cannot even let the programmer write code that is as simple as the code they would have written before they had that feature, you obviously didn't make the feature right. Because that can't be correct. In other words, leaving a giant hole in the implementation space when you create a new feature that's supposed to be better than the way you were doing it before, not even having its code be as simple as the code you had before, should be a gigantic, huge, raging, blinking symbol on the screen that goes, start over, you did it wrong, right? But I can't write this code. Why can't I write this code? I have no idea how much memory I would need to store one of these things, right? So if I didn't care about wasting a little extra memory, which you almost never do, and you don't even know that you actually are, because they might all be roughly the same. In fact, in this case, they are exactly the same size, so there's literally no reason to even care. You can't do this. You can't actually do this because you have no idea how big it would need to be. In this case, I know exactly how big it needs to be because the shape struct is the one that encloses all the other structs. In this case, I literally can't get that information. There is literally no way that C++ will ever tell me how much space I need to store the derived classes. It could be anything. Right? So I can't write this. So then what's the next thing I might do? I could try to use runtime type information, right? I don't even remember the syntax for runtime type information, but effectively what it does is it would let me write a switch statement if I wanted to write a switch statement, which is like the RTTI of shape. I think you can do this. Wish I was making this up. I'm not. All right, so I don't remember the syntax of RTTI, but it doesn't really matter what the syntax actually is. I think you can do this. I could be wrong, and you might not even be able to do this. Let's see. The type ID keyword is used to determine the class of an object at runtime. It returns a reference standard type info, which is yeah, okay, so you can. Although I don't actually see them doing it here. I mean, here's another way you could do it, right? So you might not be able to do a switch. I think you can do a switch, though. You just have, well, you know, you probably couldn't even do a switch. Let's see. It's been so long since I mean, literally, it's been like 2 decades. So I guess don't quote me on whether you can do it as a switch. Let's just hope you could. So you just do type ID. I mean, I guess you could do it this way. Right? So the reason I say I don't know whether you can do it as a switch is I don't know if that's technically considered a constant that could be switched on, like a constant integer. Because it suggests that it's a reference to a type. Here you go. Oh, but that's C+11 only. So they didn't have this back when I was starting it. But, you know, okay, so now if you've got a C++11 compatible compiler, there we go, hash code. That's what we need. So in here, in theory, you could do this. Right? Maybe. I don't know. Don't quote me on that. But, like, you could maybe make something that looks like this. Maybe. Right? So, again, what you wanted to write was this. In fact, you didn't even need to write that yet. We haven't gotten there yet. But instead, you have to write what I just wrote over there. Right? Now, furthermore, in order to get this to work, you have to have at least one virtual function, because if you don't have a virtual function, it won't create the vtable. Without the vtable, there is no identifier in the structs. So you'd need to put one of these in there regardless. It could do nothing. It wouldn't actually have to exist, right? But you would have to have one. So here's the first attempt at a clone call that's just trying to clone this thing. And it's like, well, okay, now every time I make one of these, I have to create a new one and a new one and a new one and a new one and a new one, right? And it's like, oh my lord. Because remember, none of these are doing anything yet. So the only one I even needed, the only one I actually want is circle, eventually, once we have data block, right? So this piece of code comes down in here. So that's the only one I actually wanted. But I have to write one for every single one because I don't know how big they have to be, and I can't get that information any other way, so off I go, right? So, yeah, great. So it's like, I can't do that. This is really ugly, so now what am I going to do? Well, another thing that I could do is just make a virtual function call for clone, right? So maybe I say, well, okay, I've got this clone function. It's going to be a virtual function call, and what it's going to do is return the correct type. Now, in order to do that, I need there to be one of these in every single one of these that's going to do the actual cloning, right? So this goes away, And now I've got a way to clone that's going to be in here. But again, I'm massively, remember, this is all I should have had to write. But now I'm writing all of this stuff. So virtual shape star clone. What I have to do here is, create one of these. So, if I was going to do a push struct here, I could. But, C++'s allocator syntax is new. So, the way you would see it in C++ is something like this. The this pointer is just a pointer inside a member function like this that points to the object we're talking about. So this is like passing in the shape, right? And this just has to be in everything. Again, massive amounts of duplication. I'm typing a ton for no reason. I'm typing the same thing at least 3 times. I'd have to type it, if there were 12 of these, I'd have to type it 12 times instead of just typing it once like I did before. Again, just strictly worse all the time, right? So that's why we start to get to this ridiculousness here. Because this is an example of how you might try to solve this problem in C++ if you wanted something that even slightly approaches the cleanliness and simplicity of the straightforward way to do it in C, right? Which is to say, okay, I know that I've got a shape, and I know that it's going to have a virtual base class on it, right? I'm sorry, I know it's going to have the virtual clone call on it, like so. Now, they use this syntax here, equals 0. What that means is I never want to clone an actual shape. That prevents you from ever calling clone on something that was just this shape, just a shape struct, meaning it never had a derived class to begin with. That's a way of preventing you from ever using shape without a more derived class. So if you never want anyone to really use one of these, you can put an equals 0 on it like that. And if it has any of these equal zeros, it means you can't actually make one of these. And when you derive a class, you have to supply one, right? So that's just basically a syntax that says, hey, I'm going to be using derived classes. Make sure that I'm always using a derived class, and make sure that it always has one of these functions in it. All right. So this part alone doesn't really help us because we still have to have it in both of these. But now what you can see is if we wanted to take this code out and actually share it, what we can do is use this bit right here. So what I can say is, all right, let's suppose that I don't know what the derived class is. So I'm just going to call it derived here, like in the example. Then what I'm going to do is I'm going to create this sort of shape cloner, which is going to be sort of reverse. Oh God, it's so amazing. Yeah, it boggles the mind that this is the way that people thought to program. But anyway, so anyway, I'm going to create this template class derived here, and I'm going to create a shape cloner. I don't know why I put derived in there, which is basically a base class that sits underneath this original base class and just says, okay, I'm here just to clone things. That's all I do. I have a clone function on me. I know that I'm templatized on the type I should be cloning, so I can do that. And I can do the copy as well by doing the cast here. Right? Like so. So now, when I make one of these, instead of inheriting from shape, instead I can inherit from shape cloner and pass it myself. That forces this to generate the clone function. That's what I would have had to type here, what you saw me type manually before as the virtual function, right? So let me go back to the originally asked question, which is, where is it? Which is, what do you think about the CRTP to do polymorphism? And let me look at what you said. Oh, okay. I didn't want to use virtual functions, so when I found this, I was super happy. So this is not specifically the case that you were talking about then. It sounds like the case that you were talking about is more for... let me get... Oh, there it is. Is more for this one. Unfortunately, this is a little bit bigger. So, well, hopefully you already can kind of see what I think about this. But let's take a look at this example as well then. Just so I make sure I know the actual use case here. All right, so here we've got a class printer. The printer is has some member functions. Those member functions are templatized on the type that's going to get printed, right? So you can see here they're declaring a template. The print function takes the template thing, and it just does an IO stream out of that thing, right? For those of you who don't know IO stream, this is going to be a little bit confusing, but let's see whether we actually need to dive into that or not. It might be that that's not relevant. So then we could say prints can be easily chained. Printer mystream.println.println. Yep, so that makes sense, right? You're just calling prints on prints, right? You're calling this. And since it generally... oh, yeah, I was going to say, since it returns itself, I didn't see it. There it is. So since it returns itself each time, you can keep calling member functions on it, right? So then it says, if we define the following derived class, which there it is, this is the cout printer. There's the printer base class. So a cout printer can have all this stuff called on it. And we want to have this set console color call that sets the console color. It's fine. It says we lose the concrete class as soon as we invoke a function of the base. And you can see that happening here where you're like, hey, I did a print, but the print is going to return printer, which is bad. So I want to be able to do set console color on that, right? And so off we continue going here. And we say, well, okay, what we could do, you can kind of see where we're going to go with this, right? Is if we just templatize the concrete printer class, the printer class on whatever the concrete class was, whatever the one we actually had, then we can just make it return that class, right? So we just make it return that class. Then when we are using this and we call any of these print functions, they will actually return one of these cout, the correct pointer type, the cout printer pointer type, and off you go. Right? So the question is, what do I think of that? And I mean, the answer hopefully should be obvious. Why would you ever do such a thing when the simpler solution is usually available, right? I mean, the question usually becomes, what's the specific instance you're looking to try and solve? Because it's hard to give an example. Like, I could show you how to do this particular example without making it so convoluted, but it's really kind of hard to imagine this really being a problem, because chances are the better solution, if all you wanted to do was have a console color, is just make this struct support setting a console color, right? So you're probably not really talking about something that mundane, especially because this thing probably in a real world scenario needs to know the console color for various operations it's going to be doing anyway. So this is kind of too toy of an example to really talk about probably. And I'd have to know what the actual real world example is that someone was trying to solve before I could say how I would prefer that it would be solved. But no, I don't think that's very good. I don't think that's very good for a lot of reasons. Number one, if you look at what's happening here, you're effectively duplicating a ton of code for no actual purpose. Like, the only thing you were trying to do here, right, is make it so that this syntax worked. And if you just stopped using this syntax, you wouldn't have had the problem, right? All you would have had to have done was, call these as separate lines with a semicolon, and you wouldn't have had the problem, right? So, even like this example is just not very good. And I would have to know like what a more realistic one is. Let's see. So the original questioner gave perhaps an example we can actually look at. My use case is I write a library and I want users of the library to provide their own structs for me to do my library business on, so I need polymorphism one way or another. And since it's a simulation, I want to remove all of the runtime cost I can incur. So BPAF, I guess I'm not sure I understand. If you have a library that's doing stuff on structs, why can't they just take pointers to those structs, and if the user wants, they can embed those structs in other things? Where does the polymorphism come in? Are you trying, is it because you have to call them back at like a, well, you said you didn't want virtual functions. So what is the actual reason you can't just define the structs that you operate on and then they just embed those structs in whatever it is that they're using? Like, what is the actual, what's the problem we're actually trying to solve? You have to call them back. So yeah, I guess I would ask, how is that callback? Like, what is an example of a way you call them back? They define a game, and I define in the library a generic programming framework to, generic programming framework, I assume that I'm supposed to read, to find players that play well. Oh no, genetic, you did mean genetic programming. In a library, a genetic programming framework to find players that play well at them. Well, okay, but so why does that require calling anybody back, though? Right? Like, could you just restructure the program so that you don't call them back? So, I mean, for example, right, like, just to give a very simple example, which I totally recognize is probably not going to address the full complexity of what you're asking, but it, to take it on faith that I do tend to address probably things that are similarly complex, and I usually find that there's ways to architect them to remove that particular problem. But BPAF, in particular, I create trees as expressions that contain, okay, so now we have an exact example. In particular, I create trees as expressions that contain terminals that are defined by the game, which operate on the game state, and then evaluate those games that contain if, less, equals, etc., as well as the game terminals, and then make players out of random trees and determinants between each other. Okay, so these players are like making moves, I assume, right? Like, so you're, is the thing that you're trying to store in the tree moves, like ways of making a move, or is it the state of the game? Does that make sense? Meaning it sounds like you're saying I've got something like this, Yeah. Okay. So you've got something like this, it sounds like, right? Where I've got some kind of a game operator here, and I'm building up like a tree of these operations. And I've got a bunch of operation types that I'm, working with or something like this. And then what I want to do is I want to be able to allow the user to define their own game ops, whatever those are going to be. And then I want to be able to do stuff on them, right? So the first thing I would ask is, can you just do it like this? So can you just do it where you have a thing called a game op? The game op has your left and right pointers. You have a type field in it, right? The type field says what type of op it is, and off you go, right? Your library starts its IDs at, whatever we are here, at, some very high number. What would that be? This would be 65536, so that's going to be 16 times that. So 16 times 65536, whatever it is. It starts somewhere here, right? And I just say what type of thing it is, and then we can allocate extra stuff off the back if we want to, down here, right? And off you go. Everything in the library just looks at the operation types here. If it's not one of these operation types, you know that it's a game op, and you just call the game back. Right? Makes sense? So now inside the game, this is the user of the library writes these. Inside the game, they just do like game op types. Op type my thing, op type thing 2, right? Right, so, again, like, separating two concerns here. So one concern is, do I want to write code that works well and is easy to use and easy to debug and so on, right? Oh, wait. BPF, how would you pass the information needed to create random operations to the library from the user in this framework? Well, presumably, if the operations are specialized, meaning the library doesn't even know what they should be, then you'd presumably just have like, and you've probably got library handle here or something, right? Where you're just passing it, but that's neither here nor there. So you've got a thing that's like, if you want to be able to call them back to create a random operation, then there just is one of those, and they do something like this. Well, I would probably even provide a macro like we do in Handmade Hero. So it'd be like your library name create op my op struct. I might even make it easier for them by doing it that way. And so what they would do is they'd just say my op struct here, right? And they can do this any way they want to. You can, if you want to, again, you could use this syntax if you like it, to put the game op in there. I don't generally do that, so I would probably do that, right? But the other thing you can do is, if you want, you can leave out this part if they don't need to access it. So instead what you can do is here say, all right, let's say this was going to be one of these. I could just create one of these. It would set, this would be a macro that creates a game op with one of these on the end of it. And so only the new stuff goes here. And if this part is meant to be opaque to them, like they're not supposed to touch it, then you just return them a pointer to just the base part, right? You just return them only a pointer to the part that comes after this that you've allocated, and off you go. So yeah. There's a lot of ways. So basically what I would say is library design can be tricky, and it can be tricky for a couple of reasons. Number one is it is tricky to always think through what is the actual easiest way to use this library. What reduces the number of things that, you know, that actually makes it the right decisions for making this code easy to use, right? Like I would even argue probably at this point that I would have probably tried to get rid of some of these callbacks. Maybe this game process callback is unavoidable, but this create random op callback is probably very avoidable, would be my thought, because you probably could create them in batches and do a loop, which I would think would probably be a better idea, but that's beside the point. I try to eliminate callbacks where possible, I guess is what I would say. But ignoring that part of it for a moment, creating libraries are pretty difficult because A, it's very difficult to think through all the architectural possibilities and what actually is the easiest to use and requires the least number of special purpose things. You know, one of the nice things about stuff like code like this too that people often forget is that not only is it simpler than having weird derived classes and people trying to trace through these virtual function calls going through a library and all this other stuff, but it also works on everything, right? It's like if somebody wants to run this from Python, they don't suddenly have to, you know, have some binding that does nutso stuff to make a derived class jump through virtual function call, clone, whatever work, right? Because if you just have a thing that takes a pointer and receives a pointer, like everything can kind of just do that. And it's not very difficult, right? So it makes it a lot easier to bind to other languages. But anyway, ignoring all of that, you do have a secondary problem with creating a library that is a real problem because you are creating a library. And that problem is that other people have weird notions about what is and is not effective, right? So it would be great if you worked these things out, and you know, maybe you don't like what I put here, and that's totally fine, right? I'm not saying you have to do it this way. I was just trying to give you some other ideas. And I don't even know if that's where I would land on it, right? I'd have to go see your whole library, think about it for a while, decide what it is that I really thought was the right way to do it, and blah, 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 right? But it would be great if after you did that, if you did a good job, you put it out there, and what people were really going to evaluate it on was how effective it really was to just program that. How few errors did they have? How quickly were they able to do it? How easy was it for them to read? How easy was it for them to use in other languages? Blah, 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 right? The problem is they're oftentimes not going to do that. So oftentimes what they're going to do is they're going to come at it and they've got just this weird attitude of like, well, if I don't see lots of templates and base classes and things, or I see someone cast something, like if there's a cast, the code is awful. It's terrible, right? Like this library sucks. In reality, that's just poor programming. Like that's just poor analysis. They're not doing a very good job realistically assessing whether this library is good or not. And unfortunately, especially if you ship a commercial library, there's not much you can really do about that. You're going to have to cater to certain pre-held ideas that people have that may be erroneous. You know, it's just it's not. What's the weird word they use in politics? faith-based versus reality-based or whatever. You know, they've got these terms that they like to throw around. It's very much like programming is a faith-based discipline these days, right? People don't have any objective metrics that they ever try to employ. They don't even really test things to see which ones are more effective. They just have like a belief in some things that they think either someone told them were good or they somehow came to the conclusion were good, and they're not really willing to evaluate them based on how effective it actually was for them to use, right? And so I don't pretend that these are necessarily the right answers, even if they are the best. So yeah. BPAF said, the thing I liked about the CRSP approach is that it makes somewhat clear what the interface is. You have to implement these methods and have this data, and I can do the generic tournament job. That is your base class that you can comment, and you can have multiple customization points with multiple template parameters. Yeah, I mean, like I said, I don't know. Is it really worth it though? It just doesn't seem very good. Because again, like, what if you wanted to serialize this tree? Like, what if you want to save this to disk? How are you going to do it? Right? How are you going to do that? I mean, you're going to need an enum in there at some point, I would argue. And, you know, it sounds like you already have one. Once you have an enum, you kind of don't need virtual functions anymore, right? You can just write a switch statement, and almost always the switch statement is going to be cleaner. And the same is true for the allocation. You kind of want that to be in your library, because again, if you want to serialize, you need to know how big it is, and you probably want to be able to know that ahead of time, even if you have a callback that allows them to finalize it in some way. I don't know. It's tough to say. But I would just say, unless you it just doesn't seem like the kind of situation that really calls for inheritance at all in the C++ sense, because you can do it with, you know, data style inheritance that's just going to be more flexible most of the time, I think. And BPF, the other thing about it is, it's not even so much that you extend the enum, because really, they are sort of defining the enum, right? You make sure your things aren't even in the way, so when they do it, they don't even have to know that you've got high order stuff up there. I mean, you want to document that in case they accidentally hit it somehow, but basically, they can just define... One of the things I try to encourage people to do is when they're making libraries, switch the enum order around so that you're using the high values and they're using the low values, right? So like all your stuff has this bit set, for example, now, and theirs doesn't. So you can also tell the difference between one of their types and yours by testing the bit. And that's really important because, again, it takes out a step of understanding. They no longer have to think about the fact that you also have enums in there. They can just act like they're the only one who had the enums, as if they wrote the code themselves. It feels very comfortable for them, right? BPAF, here's the thing. If I want to generate trees for different choices that need different languages, I use multiple template parameters. In your framework, I'd have to put the enums at precise points, I guess. I guess I just don't know what it means to say that need different languages. What does this mean? I'm sorry, I just don't think I understand the goal. By different choices, I mean you could have 2 choices for a game turn, and you might want to have trees that use terminals that look at different aspects of the game. BPAF, for example, imagine a game where you have the choice to play or pass, and if you decide to play, you then have to make a move. Well, but aren't you just talking about game state dependent operations? Like, I mean, isn't that just something here that would say this? Like, are we not just talking about that? Or, I mean, another way to say it would be, if you just want the player to be able to generate different random things depending on what the state of the game is, then isn't that just something they can do inside their random op callback if you give them that information? Like, why do they have to have different enum categories? Because who cares? That's up to them, right? Like, they are the ones who know what their game state is and how many permutations it might have and which moves make sense from any particular point, right? Well, BPF, why doesn't the player generate the random number? I mean, shouldn't they be the ones who... Wouldn't they be the ones who would know from looking at the game state which enums are even valid at that time? I mean, am I missing something there? I agree. It's kind of difficult for me to really know, like, asking design questions about stuff like this is kind of hard because I'm not familiar with the actual library, right? So I'm trying to sort of guess what's going on, but I don't really know. I guess let me just make the general point. So, typically speaking, it's important to pick the things your library does and doesn't do based on whether or not you're creating more work for them to have you do it, right? So for example, I'm not saying this is actually your case, so this may not be anything like what you're facing at the moment. Let's hypothetically consider, just temporarily, the case that I'm about to describe. So let's suppose that I do have a thing where I've got a move tree that I'm trying to create. I'm trying to create moves or something. Not genetic algorithms, but just moves. And at any given time, only some of these moves are valid. So I only want to create moves that are valid in that context, right? So there's 2 ways we can go about attacking that problem from the library's point of view, two broad categories. One category says, let me try to communicate to the library everything it needs to know in order to correctly guess which moves are possible at a particular point. Another one is to say, let's not do that. Let's instead just give the game enough information for it to make that decision and let it make the decision itself. Right? Most of the time, the second option is actually going to be better because the amount of work the person has to do to sort of describe their game rules to the library is probably way, way more work than just allowing them to inspect their own game state structure and generate what the moves are possible at that point for you. So flipping around the way you look at doing it there is oftentimes the right way to go. You can even provide them utility functions that make it so that they can build their random stuff out of your random picking utility functions so that you can even make it easier for them to write that second case, but focusing on making it easier to write the second case is often a better choice than trying to write the first case, right? So I don't know how closely that maps to anything that you're actually trying to do, but I'm just trying to say it's good to be, when you're writing a library, it's good to be in that mindset of, am I actually just having the user do something here that they shouldn't even have to be doing? Because it'd be way easier for them to just do some other equivalent operation that works more cleanly. And could I then provide library functions that make that even easier to do? Because chances are I probably can. Like with random picking and stuff like that, could I provide a lot of good functions that are like pick 1 out of n or pick dependency, this to this and stuff, right? Like, can I just drive it functionally there? And a lot of times where you see that mistake get made is in data versus procedure. A lot of times what people will do in an API is they'll make the mistake of thinking that the easiest way to make something complex is by having the user create a bunch of interconnected data objects and then have all these callbacks on those data objects, right? Kind of like sort of the things you were describing here. But oftentimes the easier way is to flip that process upside down and say, let the user stay in charge, let them create the tree, whatever the tree is, using functions that I use to make it simpler. That way they can drive the entire process from the outside. The classic example of this, by the way, I can describe it to you, is, let's call it node graph disaster zone. So the classic thing that you see happen in APIs all the time is they're like, and I'm talking about stuff like anything that's like AV processing based falls into this trap all the time. No idea why. It's like catnip for AV processing people. And they're like, all right, so here's what we're going to do. We're making an audio API, right? Now, an audio API is like the simplest API in the world. There are no APIs that are simpler than audio. Like console I/O maybe, but console I/O and audio are basically the same problem because console I/O and audio are both about one-dimensional input-output streams that process at a fixed cell size. So it's almost impossible to get an easier API than this. So these, audio APIs, there should have been one of them. It should have been perfectly clean, and we should all have used it for the past 30 years. Instead, we get into this node graph disaster zone, where it's like, all right, here's what we're going to do. People are going to create these like interconnected webs of data nodes with procedure calls like maybe on them. And it's going to create this like filter graph thing that'll have like, all right, there's an input source filter node, and it goes into like the reverb filter node that goes into the chorus node, and then like the multiplexer node, and then that's going to like loop, and you're just like, okay. You look at the simple tutorial for one of these things, right? And the correct API tutorial would be something like play foo.wav, right? this is the one I would write, and they've got this 15-page example program, simple example program, that's like create wav source, A equals create wav source, A arrow source equals file source, A source, and maybe this takes that foo.wav, right? And then they're like, okay, B equals create speaker, dest or something, and B probably more. There's a C here, which is create, resampler or something, and then it's like A out, or like set out of A to be, the resampler, and set the out of C to be the speaker, and you're just like, and then all at the end, then it's like there's something like go, and that maybe plays your wave file like 15 years later, right? And it's just, there's a fetishism that somehow arises about creating what you believe to be data structures that are themselves programs, and you never realize that just writing the program would have been better, right? If the person could have just written, load wav reverb wav, whatever it is, well, it's not wav, it's like A equals reverb A chorus A, B equals multiplex A, out A, right? This is trivial for someone to understand, and they don't have to go thinking about the structure that was created because it works in the order that it's shown, and it's 100% stateless, right? So I never have to worry about stuff like, oh God, like, wait a minute, what if I wanted to change this later? Like, how do I don't even know. I don't remember. I got to save all these object pointers and all over the place, right? So it's just, the general concept here is like, don't turn something that's just a set of function calls that could be a procedure, that the user can make their own tree. If they wanted to store this tree, they could just make this tree themselves. And then it's their structs with their own types. They can store all the extra data they want. They can rearrange them however they want. They can do whatever they want. Don't enforce the tree on the user. Let the user enforce the tree on you, and you just provide them the tools to build it. Can often be much more powerful, right? So yeah. All right. So I'm going to wind it down. We've done about 2 hours here, I think. I'm going to close this. All right. Woo. There we go. All right. Thank you, everyone, for joining me for a Handmade chat. I apologize we couldn't do any programming today, but like I said, based on the crash yesterday, I think we're going to take the time to reset up the streaming setup or rebuild the streaming setup so that we have something where we've got a machine that's not doing the streaming, that's the one we're doing the programming on, so it can crash and go down and do all sorts of things. And I will try to make sure that's a machine that can run a graphical, a GPU debugger on it, which I think is pretty important and would allow us to simplify our lives when we're doing our lighting development. So we'll make that happen. It'll also be a modern graphics card, so we can use OpenGL 4.5 if we want to, or anything else nutso we decide to do, although I don't think we should have to. It seems like we're relatively stable at 3.3. I don't know, maybe we won't be. But anyway, so we'll take care of that, and I will see you folks back here once that is rebuilt. Like I said early in the stream, I will be away this coming weekend, so I won't be doing a stream anyway, which gives us the perfect amount of extra time to try and get machine parts delivered for the new streaming setup. So we'll do that. And about 2 weeks from now, hopefully, unless everything goes disastrously wrong, I will be back on stream with a new setup that we can use to keep working on the lighting we were trying to finish up before. So thanks for joining me today. I'll see everyone back then. In the meantime, if you do want to play around with the code, again, handmadehero.org, you can always pre-order the game. It comes with the source code if you want to play around with it. If you do want to stay up to date with other folks who are working on the project and ask questions, we have a forum site for that. Patreon page to support the video series, a schedule bot that tweets a schedule at you so you'll know if we are in fact going to be back 2 weeks from now. The schedule bot will say so. And an episode guide if you need to catch up on old episodes of the series. That's it for this week. See everyone back here in about 2 weeks. Have fun programming in the meantime, and I'll see you on the internet.